Hello everyone. In this video, we will learn how to do the FTIR data analysis. For that, first we will plot the FTIR data in the origin via CSV file, and then we will do for the analysis the baseline correction. Baseline correction has been done for those data which are not properly aligned and their values start from the zero. So for that we will see how to do the baseline correction, subtracting the reference data, etc. And then we will see how to do the signal processing, that is smoothing of the data, how many number of points are required for the smoothing of the data so that we can see the proper transmittance. And then after the complete signal processing, then we will see how to add the peak value in the FTIR data. In order to find out where exactly the peak value is, how we have to do in case of the FTIR data. And then lastly we will see how to do the spectra designing so that the proper presentation and visualization has to be done. So let's begin. Let's start the analysis of FTIR data. So for that we will open the origin so that we can import the file. So here we will now open the file of the FTIR data which we got. For that, go for the file, open, and we will open the file, and it is in the format of make sure it should be the SKY data. So basically this data is always in the form of the CSV file. Open it. So here the x-axis represent the wave number and the y-axis represent the transmittance. Just select both, and here from the line option just plot. So this is how our data is look like. Since as you can see there is no proper baseline correction has been done in the raw data. Instead of starting with the 0 and with the flat, it should be tilted. So now what we have to do, our first step is we have to do the baseline correction so that we can properly align the data. Before that, first we will go to adjust the scale. So in order to set the scale, what we have to do is simply click on the x-axis, double click. So here this box will appear. Select the scale. Now here we can select the scale and set as per our requirement. In case of horizontal also and in case of the vertical also. So for the horizontal, let's start with the 400 and it go up to 40. So here now our scale changed from 500 to 4500, but here we have the data till 4000. So it's better we can have the scale start with the 400 and go to the 4000. So here we got. So once it is done, just go for OK. So to start with the baseline correction, we'll go to the analysis. Then under the heading of analysis, here peak and baseline, and from peak and baseline, peak analyzer. From peak analyzer, open the dialog box. So here our dialog box will appear. So what we have to do here, under the section of goal, just click on create baseline and then next. In the second, on the next, there is no need to change anything. It should remain as it is. Smoothing method, current number of points, enable out point, it should remain as it is. Again, go to next. Now, as you can see, there are some points appear which are aligned on the graph. Now at this stage, in order to make the proper baseline correction and there will be no error, so what we have to do, we have the provision that we can add the points. So here we have the option baseline anchor points. So here what we'll do, just simply add. As soon as you click the button add, again you got this screen. So what we have to do, in order to add the point, here it is already written. In order to add the point, just simply double click. See, as you can see, still there are some points which we can add so that we can get the proper baseline correction and the chances of error will be very less. So I'll add, just simply double click on the line and add the points. So it's up to you how many points you want to add. So this is how you can add the points. So once you're done with the points addition, simply go for done. So as soon as you click the button done, here you can see the points appear. Now what I'll do, in the baseline anchor point, just simply go for modify del. Modify del means delete. Modify. Now here our next step is, since you can see that the points and the original graph are coinciding, but in order to do the baseline correction, that this red line along with the point should lie above the original graph. So we have to shift this line above to this our original graph. Just simply select the point, drag it like this. So this is how you can drag the line. So this way we can drag the points along with the line. So once we're done with the line, just simply done. Now what is our next step is, in the preview, go for subtract. So here you can see how beautiful now the graph looks like. So this is the proper baseline correction. So this is just the preview mode, that at the end you will got this graph. So what I'll do now, I'll go for the finish. So this is how we got, this is the baseline, the correction we need to done, and this is our data. Now the point is, we need to subtract so that we get the final graph with the proper baseline correction. So for the subtraction of the reference data, what we have to do, go to the analysis section. Under the analysis, data manipulation, and in the data manipulation we have the second option, subtract reference data. So just open the dialog box. So here we have 2 points which we have to see. First is the input, which is already our original data of our graph, of original data of the FTIR, and for the reference, just simply click over here, and this should be the plot 2, which is the baseline of percentage. As you can see, it both has to be subtracted. So for the reference is our baseline of, with the name percentage T. Basically T represents, as I told you, the transmittance. So here it is. So now what we have to do, simply subtract. Now the subtraction is done. So don't get confused what happened to our graph. So after that you'll go to the Project Explorer and open the book. So here we have our subtracted data. So just simply select our first and second column and line. So this is how our graph look like. So this is the proper baseline correction which is required for these kind of data. So now as per your requirement, you can easily set or change the scale. For example, it is started with -5 and here you can see there is nothing at 0. So double click on the scale 400 and it is going till 4000. Apply, and you can also change the scale on the y-axis also. It is start with the 2.5, 0, and maybe not from the 0 but -1.5. So this is how our graph now looks like. So this is the way to do the baseline correction. Now the next step is the signal processing. For the signal processing means since we got the transmittance on our y-axis, so it means the signal, as you can see, at some point the sensing is very high, so we got the very large peak, and at some point the sensing is low, at some point the sensing is medium. So in order to see the proper peaks and sensing, the next step is to go for the signal processing, and for that we need to do the smoothing so that we can see proper signals. So for that, again, analysis, signal processing, smooth, open dialog. Here we have got this. So in that there is nothing to change. This is polynomial order 2. Now the points of window, this is the point. So for this method, just switch to adjacent averaging, and number of points you want, there should be a smoothing. So the smoothing has to be done between 5 to 20 in between, because if you smooth at extreme case, so what happen, nothing you can see. So for the proper clarity and sensing of the signal, let's do with 10. And here we can see the preview. Okay. So the smoothing, the red one represents the smoothing. Just simply double click on the graph, workbook. So this is our smoothing. Select and plot. So this is how your data looks like. Since the graph is already very clean, so there is no point to do the smoothing. In case if you have so much of noise, so in that case the smoothing is required. For example, I'll go again for the smoothing, open dialog, and let's say we are doing for 20 points, and here is the report. So it is done with the 20 points. So let's plot. So here you can see how the graph looks like. So it is for the 20 points, and it is let me plot for the 10 points. So here you can see this is for the 10 points, and this is how the 20 points data look like. So we have used 20 points for this smoothing, and here we have 10. So as per your data conditions, the noise available, you can apply the smoothing number of points, but please don't go beyond the 20, because otherwise you will not get the proper result. So this is how the smoothing is done. Now this is how the smoothing has to be done. So just give the name, wave number, and its unit is per centimeter, but I'm just writing only the name, and here it's transmittance. So let me just bold and little bit increase the font for the better visibility, and here let me change the scale from 4500, because this is how the FTIR data looks like, and just increase the increment from 500 to 1000. This is how the data looks like, and go for 4000. Okay. So this is how the graph looks like. Now what we have to do, our next step is to how to insert the peak values. Okay. So for that, what we have to do, we will go to the graph. Under the graph, we will go for add straight line, where it is add straight line. So here this box appears. Now they are saying uh, how you have to add the line, since we have to add the points vertically. So it is already, and we are selecting the value 2000. It should be in between 400 to 4000. So apply, close. So this is how the line appear. Now I want to calculate the peak value. So for that, I just simply move this vertical line to the peaks and write the values. So I am just moving to this. So this is the value. So what I'll do, just select text over here and write the value 1685, and let me change the color. So now the red. Now again I just move to another peak. One three eight two. So text 1382. Change the color. Then now again move the cursor. Sorry, our line 1289. 1289. Move the cursor. So this is how you can calculate the IR peak values of the from the FTIR data. 1173, 1173. No. 1008, 1008. And we have some small signal peaks also. 8, 885, 885. So this is how you can add the values. It gives the exact value. Just simply drag the line on the desired peak. 734, 734. And once you done with, just double click, just simply click the line and delete. So you can easily change the color of the numbers, the peak numbers, and in fact you can also change their orientation. So what I have done, just click, right click, then properties, and in the properties rotate. So it should be 180. Okay, I'm sorry. Properties 270. So this is how it looks like. Yes, 70. So this is how you can simply right click with the number, go for the properties for the proper visualization. You can rotate. So this is how you can add the peak values in the graph. So this is how our graph look like now. This is the part we have done for the FTIR analysis. So for now the designing of this spectra, how exactly the proper designing of this spectra, what we have to do, it's just nothing. Let me first properly align them. So we are just doing nothing, only going for the property and changing the rotation. So now with this, let us add some small line, and let me just also increase the scale so that the value can easily be seen. Now it is much better, and let me reduce the scale also from the x-axis 3500. Now it's look good. So what we have to do, we have to add a small line which mark the peak, and here it just make it 1.5. Simply copy and paste. So I'm just moving this small line to the point where we have got the values. So here is the again the line which indicating the points. So this is seems to be very simple, but this is important for designing and proper visualization and representation of the FTIR data. And the last one. So this is how we have arranged the values, and let me again double click on the scale and increase the increment. So now it's look good. Perfect. Now for the wave number, the unit is per centimeter. So centimeter minus 1, and then bracket close and completely select and bold, and just in the same way for the transmittance, the unit is percentage. Transmittance is we have measured in form of the percentage. Bold. Now let's also increase some points of the data, and now from here just provide the axis to both the side. Simply I'm just clicking and deleting because we don't need any axis detail on these sides, and just simply click and increase the thickness. So this is how your transmittance data looks like. If you want, you can change the color also, and here you can name whatever the data name is, and just simply right click, go for the property, and What's happening? FTIR data, select, bold, OK. And here we go. So this is how the designing spectra and the proper data of the FTIR looks like. So after that you just simply go to import the image, export the image from here and copy paste. So this is how you can do the things. Now I can also show you how to export the file and save the image. Just simply right click, export page, and here what you have to do, image type, which type, like TIF, in which format you want. Let's say I want in the TIF, and here I can give the name of my file FTIR data, and where it has to be saved in the path, it has to be saved on the desktop, right? So let's come downward and see. Here the color space is RGB, and this the resolution we want. It should be, the better is 600, right? And so this is you can do and apply, and then it will take some little bit of time to export the image. Okay, so the image is now saved. I will show you. So we will go. So this is all about this video of the FTIR data analysis. Thank you very much for watching.